Okay, then I'm going to introduce about meaning as a pretext text, improving self-supervised learning in tabular domains. This paper published on ICML, which top conference on machine learning field, and this paper conducted by LGAI Research Data Intelligence Team. So let's read the abstract first.
Which journal?
It's published on ICML top conference.
Okay.
Then I think this is the gap sentence to address the challenges in self-supervised learning framework. We propose a novel pretext text based on classical meaning method. Okay. Then tabular data sets are ubiquitous across diverse applications, such as financial field. They conducted the tabular data set using stock information or something like that. And then healthcare field, they construct a table using medical records. And the e-commerce field, they construct a tabular data set using customer information. And the manufacturing field, they construct a tabular data set using production information. So the tabular data sets are typically structured with the row representing individual samples and columns representing heterogeneous features, which a combination of categorical features and the numerical features. Okay, due to the heterogeneous features, it is difficult to train a robust model. There is example in here. When this guy buys some goods, like Dr. Hyun buy toys to his daughter, and then Hyungjun buy punishing to maybe his parents or something like that. Okay, and then
Question.
what was your name?
Buy some clothes.
Okay. And then let's check the categorical feature first. Dr. Hyun is really good at critic, and Hyungjun and Dongju is not good at critic. So let's in this condition, which grade did the company gave them? Maybe Dr. Hyun is good at critic, maybe he's VIP, or Hyungjun and Dongju is just not good at critic, so maybe they're lower grade or below or something like that. So let's check the numerical features. Dr. Hyun will buy some stuff a little, but Hyungjun spends more money and Dongju spends more and more. So guess which person should be get a VIP grade?
먼저
Yeah, Dongju and Hyungjun is a premium and Dr. Hyun maybe the normal. Let's check the actual grade. Dongju was the VIP and Hyungjun is the normal grade. And Dr. Hyun, sorry, but he is not a valuable person. Okay. In this example, there is really hard to classify the level. So of course, the machine learning model or deep learning model hard to train, hard to classify this kind of level, or train a robust model based on heterogeneous features. So to train a robust model, the feature heterogeneity must be mitigated. How? The binning method. The binning method is being utilized to mitigate the feature heterogeneity. Here is the input. Then let this input into t discrete intervals and mapping this continuous input to discretize the bin. In details, this kind of original input is here. Then let this input into 10 discrete intervals and mapping to the discretized bins, like ordinal bin index or the nominal bin index. So the bin method mitigates the feature heterogeneity by setting all features to have category type brackets. So how to use this binning method to build a deep learning model? To understand the binning method to deep learning, we compare the original and binning based model. This is the original autoencoder model architecture. Here is they trained the model reconstructing the original value. But in binning based autoencoder model, they trained the model reconstructing bin index. That is different. So the binning based deep learning model optimized the encoder and decoder networks to accurately predict the bin index given original input. Then furthermore, binning
sorry, can
yeah.
you original autoencoder model try to reconstruct the original value, but binning based autoencoder model, okay, we want to put the original value. Oh, we do not put the bin rather than bin. They put to the original value to the encoder.
Yeah.
And then output is their bin.
Yeah.
Bin is already decided.
Yeah.
Okay.
Bin is kind of quantile.
Yeah, quantile.
Like
this.
kind of, but whatever bin method is fine, or only quantile. Like
Whatever.
Whatever is fine.
Yeah.
Kind of predetermined.
Yeah,
bin.
correct. Empirically, the quantile is better. They mentioned.
Okay.
So and here, the latent variable G uses for predictions.
No, it's later. Then it's moved to transport the weights, and then to the self-supervised learning
Okay.
to transport the weights.
Anyway, everyone remember that input is original value and output is bin. And that's our current latent space V.
Yeah.
Okay.
And then furthermore, binning-based self-supervised learning has been proposed. The original self-supervised learning architecture looks like this. For example, there is large-scale unlabeled data set, such as heart rate data, and they train the model reconstructing the original value, that is the original model. And then they transfer the model and the model's weights. And then they fine-tune the model using small-scale level data. And then classify insomnia or OSA or something like that. Then we can do this kind of downstream task based on Pretext test. Okay? And then, but in binning-based self-supervised learning, they train a model using large-scale unlabeled data set and train a model using reconstructing bin index. Okay, and then they similarly transfer the model and model space and then trained using small-scale label data. And then we do same as downstream test based on binning-based pretest tests. Yeah. So,
Okay.
okay, and then
Second,
So the output of decoder is used to predict something.
so here reconstructing bin index means actually originally is time series data, right?
Yeah.
So here is also time series data of the bin.
no.
Oh, really? Original data, this time series data goes to just one number? Or
No, like
it's a
I think there is a, for an example, there is 5 timestamp time series
then
data. Yeah.
so that each one becomes bin.
Yeah.
So that it's a time series of the bin.
Yeah, right. Time series.
Bin, right?
Right.
Okay. Then can you go? Okay. Okay. Then maybe. And what is his point is, we have many whatever time series data, but usually there is no label. Kind of. Here we have 40 people here. Let's say you have all this smartwatch. We have many of your time series data, but is there anyone you have a certain disease? You've never been to hospital, right? So that means you're no label here. I'm the only one who have a label. I'm old enough to know what kind of disease I have. Okay? In this situation, what we can do? You have only one label data. Can we do any machine learning? No. So, but what we do is, for your all original data, we plug into this auto-encoder, so we will reduce the dimension. But the goal is we want to reconstruct the original data set. That means at least this low dimension space is good at capturing all the features of the data set. Okay, so using a large data set, we will decide the low dimension space. Up to here is okay. And then we will plug in the new data set to here so that we will reduce the dimension. Okay? And this dimension is now reduced from this space. So now we have only a small, very small number. Because it's low dimension, it could be 5 dimension or 6 dimension. And what do you think? Do we need a lot of the label or not? Here time series is like 1,000 dimension. Then to classify the 1,000 dimension, how many label do we need? At least 1,000. But here the 5 dimension data set. What do you think? Much easier. So that's the key idea. But what he say is, it's a little bit confusing here. Rather than this, here is a time series data, but now it changed to the bin means it doesn't look like this, like a stair. 0, 1, 2, 0. So that's the key differences. Is it good? So that's that's correct? Okay.
So the binning method reduces the heterogeneity. So we can try to train the tabular data set using this method. Okay. And in addition to mitigating feature heterogeneity, how can we train a more robust model? Using input transformation. Input transformation mitigates the minor error in data set, such as noise and outlier, and makes the data distribution more manageable. There is 2 ways, but the first way is masking the value. Here is the original feature matrix. Then they randomly generate the mask matrix independently sampled from the Bernoulli distribution. And then they reconstruct the input data and then get into model. So this is only apply masking method. And the another way is masking and replacing value both. Like first one is replacing mask value using constant metrics. Here is the original feature matrix, and we reconstruct the matrix using calculate the mean of the feature matrix, and then they automatic product with the masking matrix, and then they reconstruct the input data.
I see. For some random position, they took the average.
Averaging. And then they replacing mask value with random matrix. Then they randomly sample based on the uniform distribution. They sampled it and then they shuffle the replacing matrix, and then they just couple to the input data.
Yeah, see, they put the randomly selected value from the original data to the random place. Well, I think, yeah, everyone, I think this is a good idea, right? Maybe last week we studied a surrogate test, right?
Okay.
Kind of, for the surrogate test, we permute something, but this might be another way to make another distribution. Kind of, by doing this, we can make thousands of the data set.
So after this input transformation, the model is trained by optimizing the Vincent and Win-Recon losses. In original self-supervised learning, they optimize mask set loss. This loss function predicting which features has been masked in the input sample. And another loss function is value recon loss. This function reconstructs the uncoupled samples from the coupled counterpart.
Oh, sorry, we don't understand it.
There's in here the couple meaning
So from the beginning.
Here
Okay.
it's just reconstruct the input data. That means like that.
Okay. So the first one first, the mask set loss.
Yeah.
Can you explain what is a mask? Detecting the mask feature.
Where the mask is on the
So we give a mission that
mission to
identifying the where is the
where
mask.
is the mask here.
Oh, isn't it? It's easy that just detecting the average value, isn't it? Because all the masks have the same value.
Right.
Is it difficult job for them or not?
This is for the original self-supervised learning.
Okay.
Yeah, so they just detected the mask part.
So please think about it, everyone. So, we masking the certain random place with the average value, and then we are giving a job to the neural network that detecting the where is the mask happening. Is it difficult? Which feature have you masked in the input sample? Okay. Then what about the B then?
Being
Bottom.
bottom.
Construct the original value.
Yeah.
That could, you mean the randomly change the value. We want to reconstruct the original value.
Original value.
Is it possible? Anyone who have an intuition for this? And we want to make autoencoder model. Okay, we want to find the latent space. But for the latent space, original goal was we want to reconstruct the original value. But now we are adding either asking to detecting the where is the mask or where is the randomly changed.
Is it the only laws that will be used to autoencoder training, or is it it will be added to some other
additionally,
additionally.
somewhere.
Kind of originally is reconstructing
Yeah.
the original matrix, maybe plus this.
Plus this one or just
Oh, here is a little bit confused. Okay, next.
okay. And then in bin-based self-supervised learning, they optimize the bin record losses. They reconstructing the bin index as a ordinal bin index. They just input this the original data, and then we want to target the ordinal bin index.
Original being before the corruption, before we mask it.
Yeah, before the masking.
Then left side A might be rather than detecting the masked feature, they should find what is original value of the masked feature.
Right.
Right. That makes sense. Okay. And
Then another thing is bin-set loss function, and this function reconstructing the bin index as a nominal bin index.
anyway, A and B goals are the same.
The goal are the same, but the target is the ordinal or the nominal.
And whatever. Okay. So everyone is okay. So anyway, the goal is now we masking the original value, and then we give a job that guessing what is a hidden value during the latent space. Okay.
Then by optimizing this binning-based losses, the model was evaluated on 25 datasets for verification. This is the 8 benchmark dataset in binary classification. This distribution looks like this, and 9 benchmark dataset in multi-class classification, and 8 benchmark datasets in regression test. So, with binning method, binary classification performance is consistently improved. Here is the binary classification benchmark dataset. And without the binning, there is no just one state-of-the-art model in here. And with binning, there is a lot of SOTA modeling here. So there is improved performance by applying the binning method.
What do we have to compare with the top and bottom? The value is higher than mean square.
Yeah,
Accuracy.
It's the accuracy. So the bigger one is better.
Okay.
So these two parts means like the just input transformation,
Okay.
and this one is which loss function we use to train a model.
But there we didn't use the B. They use original raw
Original,
data.
yeah, original. This is
Tabular data.
yeah, tabular data.
And then when they just add the binning,
Meaning,
improved. And
then
is it really improved? Don't know. What do you think, everyone? Do you think
What is average rank?
just for the I think just make it average in each data set maybe.
For each data set they have rank and then they average it.
Yeah, right. This is like each data set in here. Columns are there, and then maybe they just calculate it.
Okay.
X and 10 in requirement. We apply with mask data or
In here, they use the masking data just two parts in here.
so can we calculate the two losses even without masking?
Yeah, it was, but it was not good at performance, so they just erased on this thing. could be applied. Okay, and then in multi-class classification, there is some improving here. Using masking and replacing value and choose some bin recon loss function. And even performance improvements are observed in regression test. Okay. When you use the binning method in here. So just compare with the tree-based model and deep learning-based model. The binning-based supervised learning showed a superior performance in binary classification when we applied multi-layer perceptron in encoder. They get a best state-of-the-art model performance in here. And then in multi-class classification, when we apply TF transformer, which apply the featured tokenizer in transformer model, that makes the state-of-the-art performance in here. And even in regression test, when we applied T2G former to the encoder model, they get a even the SOTA performance on the result. So this is the totally performance table. And then, in summary, we train a model based on binning-based pretest task, and they even get a state-of-the-art performance. Okay, and then the codes are available in GitHub, and in the GitHub, the main SSL, the Python file is the main source code. Then if you guys wanted to use this code, then please use this file. And they release the pre-trained model suites, so we can easily use this kind of method in our individual project. Okay, that's all.